absolutely.
All right.
We were discussing, Sean, with Carrie, the design study section that we need to present and get approval from the instructor. We can move on to the next tab that we have for this week.
Okay.
Yeah, so we check already samples and opinions that you provided to us. So I agree with you. We can go with one of those items, examples that we can work with.
Yeah. I definitely think doing something like that rather than, you know, finding a survey of people type of thing would be easier and better.
So with that in mind, what would one of them stand out more than the others for you guys that you thought were?
I was thinking about the number of potato chips in a bag of certain size.
Okay.
Right. Yeah, I was thinking that or the crackers. I mean, I think that would be something like that would be a good idea.
Yes. That one looks good for me, but there is a sheet that we need to fill out and then to submit for the instructor to approve it.
Okay.
Okay, so do you want to go first with the material for this week or fill out this form?
Either one. I mean, do we need to record our discussion about our study or?
Not necessarily, but just to make it together, I think.
Yeah, I think that's, so if you want to go through the material, record it, and then we can stop recording and chat about what we want to do for our project.
Yeah, so let's go through the material real fast.
Is the internet
What's that?
Is my connection okay?
It seems to be okay. It's a little jumpy, but it's gonna be all right.
All right.
Okay, so then for the material for this week, for part 2, we have one exercise to, and it says welcome part 2 with your group preparation. So we have number 4. It says there will be taken on whether consumers are label users to pay attention to label details when are men and women equally likely to be label users. Determine if the proportion of men who use labels are different than the women. Of significance of alpha equal 0.05. So the first check for the requirements. So I did that, and it was compliant with both of the requirements.
Right.
Did either one of you watch the videos as well as do the reading?
I did not watch the video.
I didn't.
So I watched the videos, and I think it's Brother Lamar that does all of them from the math department. He said you can crunch the numbers. He said, but in this situation, it works really well to just put them in Excel. He says it's important to know how the numbers work, but Excel is good. So that's, I mean, I crunched them and did them in Excel, but that was his advice.
Yeah.
Okay. I did it manually for this exercise.
Right, and so did I, and they turned out to be the same, but it just.
Yeah, I think it's always good to go through it and make sure you know how to do it, but then it's nice to have the Excel to know you're doing it right.
True story.
Okay, so who wants to read next one?
So B, we got stick the null and the alternative hypothesis. So the null hypothesis P1 equals P2, and the alternative is P1 does not equal P2.
Correct.
Okay, and then for C, find my paperwork here. There it is. It says compute the test statistic, and I ended up with Z equals 3.309.
Yes.
That's what I got.
Then for the p-value, come up with 0.001.
Yeah. And then with the test statistic, you know, I printed it out or I copied it and pasted it, but it's got both sides way out onto the sides where you can't really see anything on both sides.
Correct.
Yes, because that was a scientific notation having 4 zeros. So the real number was 0.0009. If we round that number, it was 0.001. I'm sorry. Yeah, 0.001.
Right. Very close to zero.
So,
So what decision do you make about the null hypothesis? Because the p-value is so low, you would reject the null.
yes.
And we have sufficient evidence that there is a difference between the proportion of men and women who are label users for shopping.
Correct. The next one was asking to construct a 95% confidence interval for the difference of the true proportions. Number 4, I came up with a lower bound 0.045 and the other 0.165.
Yep. Like that.
I had 0.166. I'd have to go back and redo it.
Well, I was just not rounding any number. So that is why I was taking the full decimal places.
Right.
Yeah, I think it's just where the rounding or.
Okay.
So interpret the confidence interval. So we are 95% confident that the true difference in proportions of men being labeled users and women is between the 0.045 and the 0.165.
Correct. Yes. So we can move on to the quiz then.
All right. All right. PTC tasting study. All right. So
Mine's not coming up. Sorry. Just a sec.
Nice.
There we go. Now it's coming up. Okay, we're good now.
excuse me.
No worries. It's fine. Okay, so then it says for the next 10 questions, we'll review the PTC, and it's given us the chart with the information. So then it says let P1 be the proportion of females in the population that contains PTC, and let P2 be the proportion of males in the PTC. The research questions for this study is given here. As the proportion of females who contains PTC differ from the population of males. And it says use the data on the table to find p hat round to 3 decimal places.
So just to make sure that I'm understanding the P1, the P2 versus the P hat, right? So the proportion for P1, is that the 52 out of 70?
Yes.
Right.
And P hat was, where'd my notes go? What did I do with that? P hat was where you.
Well, the P
Yes,
hat,
P hat, the formula for that was the number out of the total population.
yeah, so it'd be the X1 over N1 for P hat, which would be the 52 over 70 in this case for female.
Yeah.
Yeah, I get really confused with the P and the P hat also. I don't.
Yeah, what is?
On the written for this one was given us and explaining that for the formula for P, we will be having as P1 equal to P2 equal to 0.
Right.
Where the
So
formula I was thinking.
What about where the P hat where X1 plus X2 is divided by N1 plus N2?
That's the total for the sample, taking the two proportions, taking P hat 1 and P hat 2.
Everything. Got it. Got it.
Yes.
Got it. Okay, that's what was confusing me on this one here. So thank you.
Okay. So
P hat for 1 is 52 divided by 70, and P hat for P2 would be 42 divided by 59.
Right.
yes. So for P hat 1, for question 3, I'm getting 0.743.
That's what I got.
Correct.
Question 4 for P hat 2, I got 0.712.
Yes.
I'm sorry, what was that again, Carrie?
0.712.
Okay. That's good. Okay.
So then for number 5 says which set of hypotheses is appropriate for addressing the research question. I would go with the first P equal P2 and then alternative P1 not equal to P2.
Is it P or would it be the? It wouldn't be the P hat like the last option, would it?
The last option?
Yeah, because those are the same except the second one.
We're taking the.
No, it'd be P1, be the first one.
P1 and P2. Okay.
Yes, I would go with the first one. Yes, checking on my notes, it says yes. It's that one.
Like I know I went through.
It's just right, I think here the inference for two proportions. The null always will be P1 equal to P2 and the alternative equal to P2. We are using the P hat to calculate it.
Right. Right. Okay, that makes sense. Okay. Now we want to create a 95% confidence interval for P1 minus P2. And put your answers for the point estimate, margin of error, lower bounds, and upper bounds. What is the point estimate for this 95% confidence interval?
It's not the 1.6. Isn't enough 95% confidence interval? It's 95%.
So the point estimate is the z-score, correct?
I think so.
Or no,
Yes.
the point estimate.
But it will ask for the z-score as the t-statistic.
Right, test statistic. So p hat is going to be your point estimate.
But since we have 2, are you gonna state the p hat, which is for the first and second proportion? Then it's upper bound position. Put it on. I don't know if I am wrong, but on previous tests, whenever it was asking for the point estimate, it was asking for the percentage that we were taking as the confidence interval. In this case, it's 95. Is it not 1.96? Because that's the one that we're checking as reference.
Oh, okay.
That's what I'm thinking.
I'm not following you there.
So because it is the 95% interval, it would be the
Yes.
1.96. Whereas if it was a 90%, it would be the 1.645.
Okay.
Yes, I'm just taking that because the point of estimate that we're taking in reality is the 95%. So we're estimating based on 95%.
Right.
So that's why I'm going with 1.96. Because then on the previous exercises, we were taking as point of estimate the mean, have a mean, which is the percentage that we're evaluating.
Right.
It says, let me check. It says, point estimate is the
Sorry, I didn't hear that. Could you?
I think
Kevin
Kevin
out.
a little bit there. I can hear you, Carrie. Are you still there?
Yeah, I can hear you still, but Kevin's frozen.
See, I think it's P hat.
P hat. Take it back, Kevin.
Yes.
So I thought that our point estimate was your P hat when you're dealing with the population parameter. And that's where, because when you're looking at the point estimate was for your sample mean was the top of the barrel over the top.
Hmm.
How can something so simple be so confusing?
Yeah.
So Kevin, you think that it's the 1.96?
As I was reading in here a definition of the point of estimate and confidence intervals to estimate the difference in population proportions, and it says point estimate is the difference between the two sample proportions. So, which means having P hat 2.
Sorry.
And thinking it that way, it makes more sense because you will be having each point of estimate of each proportion and just having the difference of those. But with this one, as you said, it can be the 1.96 or the difference in between those. I was just Googling it for a definition, and it says as the difference between the two sample proportions.
The difference between the two sample proportions.
Having as P hat 1 minus P hat 2.
Okay.
If you want, we can go with that one, and we can see.
If that's what I'm just looking for it here in the reading. But
because if that's the case, it will be P hat 1.743 minus 0.712 will be 0.031. The difference in between those.
Yeah.
If we want, we can go with this one, and we can see if this would be right.
okay. So what is your proposed answer there then?
0.031, which is the difference in between the first P hat minus the P hat 2.
That's P hat 1 minus P hat 2 is what you're telling me.
Mm-hmm.
Which is also, I just was noticing the confidence interval on the spreadsheet, and that 0.031. If you take that from the other, then it's right in the middle of the upper and the lower.
Mm-hmm.
Okay.
Okay. So then we can try with this one then. So for the next one, it says, what is the margin of error? I am just the intervals, which is 0.123 plus 0.185 divided by 2. That's 0.154.
So I thought you took the upper and subtracted the lower and then divided it by 2.
If we take it that way, over 0.85. Yes, and because since the lower bound is negative, it will turn it into positive to 0.2 0.123. Point negative. No.
I ended up with 0.154.
Yes.
0.154.
Yes, because you have the 0.185 carry, and if you subtract the lower bound, because the lower bound is negative, it will make it positive. So it will be 0.185 plus 0.123 divided by 2.
Divided by 2.
154.
Okay. Got it.
For the lower bound, I have negative 0.123.
Yeah.
All right, so let me put this in here. 0.54. Lower 0.123. 0. That's a negative 0.123. Remember that?
Yes.
Missed questions like that before. 0.185 for the upper. Okay, question 10.
So the p-value have it's 0.653, which is greater, so we fail to reject the null.
Yep, and that would be the HO, right? Fail to reject.
The first option.
Yes.
Failed to reject the null, the first option.
And I would go with the last one for question 11, what says there is insufficient evidence to suggest that the true proportion of females who can taste PTC is different from the true proportion of males who can taste PTC.
I agree.
Because we're looking to not equal to.
Which one did you say, Kevin?
The last one?
There is insufficient evidence to suggest that the proportion of females is different. So if we rejected the null, that's not correct.
Well, we failed to reject the null.
Okay. Sorry, I messed up. There's Z. Right. Okay. So we failed to reject. Right. Correct. For some reason, my brain said that we rejected the null.
So for the next one, we have new information.
All right, for the next 10 questions, we'll review the mortality rates and day emissions of heart attacks. Different data. Of 18,000 got a heart attack during a weekday. 16,713 died. Out of 42,447 had a heart attack on the weekend. 6,155 died. So,
I'm sorry?
I'm just looking at which one's going to be the one. Looks like weekdays is going to be group 1.
Yes, weekday will be group 1.
Okay, so N1 equals 11,8,519.
Yes.
1 equals 1,673. And 2, 4, 2, 047 X2 5. Excuse me. 167.
So the conditions are satisfied.
155.
So true.
42447. Okay, so then it says let P1 be the proportion of patients who had a heart attack were admitted on the weekday. P2 proportions admitted on the weekend who died. Research question for the study is given here. Is the proportion of patients who had a heart attack and were admitted in the hospital on a weekday who died less than the proportion of patients who had a heart attack and admitted on the weekend who died? Using a level sigma of 0.05. So is P1 less than P2? That's what we're
Right. So that's
Is the last option.
the last one or first? Oh, sorry. You're right. Last one.
That's the last one because we're looking out for less than.
Less than. You're right. I was getting mixed up which way they're going.
P1 is less than P2. Last one.
So then for number 14, it's asking for P hat 1. I have 0.141.
That's what I had also.
Sorry. What is your data? P1. 0.141.
Correct.
Table to find P2.
It's 0.145.
0.145. Z-score.
Have negative 2.020.
What I got.
2.020. To the left, correct?
Yes, because it's less than. And the p-value got 0.022.
Yeah.
And the level of significance we had was 0.05. So we reject the null.
Yep.
So we reject the null?
Yes.
0.02 is less than 0.2. Reject the null.
And I would go with the third option for question 20, which says there is sufficient evidence to conclude that the proportion of patients who have a heart attack and are admitted to the hospital in a weekday who die is less than the proportion of patients who have a heart attack and are admitted to the hospital in the weekend who die.
Right. Third. Correct.
Okay, let's see.
All of them.
And yes, we got them all. That's great.
Good deal.
Okay. Well, I guess you want to turn this one off and discuss our project a little bit.
Okay. Let me just up the discussion.